Hi everyone, I'm Devabrata and this is my talk on Docker, We Still Love You. So this memes is depictive of what happened last year when Docker announced it is deprecating dockershim, and there was an havoc along the devs community, especially the SRE and DevOps. They thought, and those people, especially who weren't aware about things like container runtime, OCI, and other things, they thought dockershim removal means the death of Docker and. Uh, they thought that we won't be supporting container images built out of Docker, which is very untrue. And if you know the real reason behind the removal of Dockershim, it is for the benefit of the project and how it's indicative of how the project is becoming more and more inclusive for various container runtimes that are coming up in recent advancements in container technologies. So in this talk, I'll give you context of what is happening and how this whole things are interlinked. How Kubernetes talks to containers and how they in turn orchestrate helps in orchestration of Kubernetes, the orchestration of the containers for Kubernetes. We will be seeing what is happening in Kubernetes 1.24, and there's no need to panic. It's time to adapt, and the unlimited resources that everyday upstream devs are trying to create for end users as well as upstream folks, obviously, to help understand what is going on behind the scenes. So, as we know, at the lowest layers, the fundamental Kubernetes node is the software that, among other things, starts and stops containers, the basic things. And the thing that does this, we call this container runtime, basically. And Kubelet communicates with the container runtime over Unix sockets using gRPC framework, where Kubelet acts as a client and CRI sim acts as a server. And inherently, when Docker started, it was a monolithic service. And Kubernetes, when it started, Docker was the only container runtime that was prevalent in the market. So they came up with something called Docker shim to support the container runtime interface for Docker, because Docker inherently didn't hide this container runtime interface. But with more and more container runtimes coming up in Kubernetes 1.5 release, with the vision of being more inclusive, providing developers more options of using various container runtimes. It came up with a container runtime interface, which was a plugin or interface which enables Kubelet to use a wide variety of container runtimes without the need to recompile, I would say. So historically, if you will see, Docker, started as a monolithic project, as I have said, monolithic tool that contained the ability to set up containers along with a myriad of developers tool, including CLI, logging, storage management, network building tools, and many other features outside the core capacity to create a container. And in the vein of Unix philosophy, however, Docker eventually broke up, these components and contributed the container D. If you could see in the first thing, this container D is the container runtime component of Docker, and it has been developed as an open source project and have been donated to CNCF. So the default configuration in Kubernetes kept Docker as the abstraction layer on the top of containerd. As we started, as I say in initial days, we used Docker as the abstraction layer on top of containerd, which in turn was an abstraction layer on top of runc. This additional layers and all of the additional layers that Docker includes obviously creates maintenance headaches, significant overhead, and larger attack surface of exploits. And this is not ideal in ephemeral environment where teams are deploying code multiple times a day. So the additional layer also introduces serious security implications. And at the same time, when other container runtimes began popping up, Kubernetes maintainer came up with this standard called the container runtime interface in the 1.5 version, which we talked in the last slide. That would be a common language for communication between kubelets and container runtimes. And as Docker wasn't compliant with the standard, it required a middle layer SIM to operate. Obviously, that's the reason why Docker SIM is there. And if it would have uh, inherently supported this CRI, we wouldn't have needed this Docker SIM. And Kubernetes and containerd maintainers added a CRI SIM for Kubernetes to talk directly to containerd, which you could find in containerd 1.0. So this allowed Kubernetes to cut out Docker and use containerd directly. So this technically reduced the container capabilities. Obviously, the reason why Docker is famous among developers is its other capabilities of logging and the CLI it provides, inherent CLI and other things. But those capabilities are quite unnecessary for an orchestration tool like Kubernetes, because containers managed by Kubernetes, for example, doesn't need SSH access. However, CRI SIM, this daemon added another complexity and another attack surface for so-called developers. So how this thing functioned in container D 1.0 is, this daemon called CRI container D was required to operate between kubelet and container D, and CRI container D handled the container runtime interface service requests from kubelet and used container D to manage containers and container images correspondingly. So compared to dockershim, dockershim, the Docker CRI implementation, this eliminated one extra hop of stack. But in container D 1.1, which came up after in 2016, Cryo, when came up with an alternative to Docker, it jumped ahead of the container D's evolution and included a native CRI plugin from the beginning. And following this, in container D 1.1, you will find the CRI container D daemon is now refactored to be a container D CRI plugin, aligning with what Cryo came up. So this CRI plugin interacts with containerd through direct function calls. So this new architecture makes the integration more stable and efficient and eliminates another gRPC hop in the stack. And user can now use Kubernetes and containerd 1.1 or Cryo directly. Kubernetes talks directly via the CRI to pull an image, launch the low-level runtime, to set up namespaces, C groups, root file system, storage, everything, could be done directly from kubelet to the abstraction level of containerd and CRI and Cryo through this CRI plugin that has come up with. So now we need to understand, this container runtime and container build environment are completely different things. We can still build our container on Docker, and it can still, run on different environment, and any container that is OCI compliant would be able to be supported by orchestration tools like Kubernetes. So this again, as I said in the first slide, as soon as Kubernetes announced dockershim removal, folks that were unaware of OCI and CRI, this thing basically came up. Docker produced images. What will happen to them? This was the question. Will it continue to work in your cluster with all the runtimes? Yes, it will. It will be able to work, and because of what work Docker has done along with other foundations to build this open container initiative, which is an open governance structure for express purpose of creating open industry standards for container formats and runtimes. So it was established by Docker in 2015. And everyone follows the runtime specification and the image specification, and these two paragraphs, basically I took it directly from the OCI website, the two introductory paragraphs. You could read more about this foundation, this open governance structure, and how it is creating the ecosystem more and more inclusive for the tools that are at a higher abstraction level than the container runtimes, that is the orchestration tools. So when we talked about Docker, which started as a monolithic tool, started to scale itself and build different parts of it. So containerd became the container runtime part of the Docker, which was donated to CNCF, and it's an open source project. And shifting from native Docker engine to containerd won't be much of a change for you. Or for any Kubernetes users, especially for the folks who are using enterprise Kubernetes, like from AWS, from GCP, from VMware or Red Hat. They did not have to worry, because they have this default option of converting their clusters or putting containerd by default in their clusters. And even these enterprise folks are making people aware, and we as Kubernetes upstream dev community are trying to put up surveys, know how much prepared everyone for this dockershim removal. So yes, as I said, migrating from dockershim to other CRIs, we have direct technical blogs which no technical documentation which highlights the processes you need to sift your node from Docker engine to cryo or containerd, how to drain the node, stop the node, and shift from one Docker engine to other CRIs. So, as we saw in all these slides, the lower abstraction level is runc, that is uniform throughout from cryo to containerd to Docker. There is just an increase in abstraction level and increase of features as we go up higher in the abstraction level and the value chain. So there are few differences around the edges which you need to take care of, like logging configuration, runtime resource limitations, node provisioning scripts that call Docker or use Docker via its control socket, kubectl plugins that require Docker CLI, basically, which is an added feature to Docker on top of the containerd abstraction. So the configuration of functionality like registry mirrors and insecure registries, other support scripts. So these all things are mentioned in the updated FAQs for dockershim deprecation that is available in kets.io website. You could go and read those things. And these are the resources which majorly enlists all things, basically the FAQs. And first of all, you should know whether dockershim deprecation affects you or not, because containerd has been a part of CNCF since a large amount of time, and people have shifted to containerd even before the dockershim deprecation was announced, or even after dockershim deprecation was announced. So you don't have to worry about dockershim removal now if you have already shifted to. So you need to check whether dockershim deprecation affects you or not. And this blog is very important for everyone. And there is an endless of articles on dockershim removal and on using other CRI compatible runtimes. Those are available in kets.io website. So we saw, how container runtime is evolving with time, with container technologies are evolving. New container runtimes are coming up, and using container runtime interface CRI plugin, Kubernetes could interact with any OCI compliant containers. And until these OCI compliant containers are present in the market or are coming up, you need not worry about what will happen to your clusters. It won't stop working, and Kubernetes will be able to manage everything in your clusters using this container runtime plugin. But for now, since Docker engine has been an inherent part since the early days of Kubernetes, and it's still a part. We are still supporting any container runtime, and Docker qualifies as a container runtime, and it runs containerd inherently. But the additional tools support like the CLI and all those things that will drop off with this dockershim removal, and it's in the long run it's beneficial for as upstream Kubernetes developers, as we don't have to maintain that part of the code, and more features that used to break that part of the code. Now that won't be a headache for us. So hope this version with version 1.24 release, it goes smooth for you, and you are adapting well to the dockershim removal. Thank you. That's all from me.